Okay, good morning to you all. Today, we will be discussing another important topic called frost phenomena. Okay, and this is certainly related to cryogenics. Okay, so we will be discussing about this topic of frost phenomena. Okay, and how to handle the cryogenic fluids. That is also very, very important. So we will add this information. This topic we will now discuss today. Okay. The plan of my presentation is going to be something like this. We will introduce what is frost, the different types of frost, how the frost forms. Okay. And then we have various forms of frost, something called hoar frost, advection frost, window frost, then white frost, and then black frost. These are the different type of frost that occurs in nature, and it has a lot of effect on plants, because as you know, frost is something like nothing but the ice crystallization, and it affects the plants, and when the temperature goes down, the water content of the plants become ice, and then ice crystals rupture the cells. So the plants get damaged, right? So how do you protect this phenomena of frost? Okay, especially for plants which are producing various, items. So we need to have a protection method to take care of the plants becoming deteriorated. Then we come back to the frost at cryogenic temperatures. What is the nature of frost at cryogenic containers, for example? Then there is an important thing called Leiden frost. Okay. And then we'll talk about the frostbite. Okay, the effect of suppose you are handling cryogenic fluids, okay, or you are working in a very low temperature climate, then you get what is called frostbites. So, and then we conclude the talk. So basically, this whole thing, this particular talk is related to the complete frost phenomenon. Okay. So let us try to introduce frost. So what is frost? Frost is nothing but a thin layer of ice on a solid surface. Okay. It's an ice formation on a solid surface. You call it as frost. And this forms because of the water vapor. It takes the water vapor from the atmosphere. Normally, this water vapor atmosphere is at temperature above the normal freezing point of water, and it comes in contact with the solid surface. So once it comes in contact with a solid surface, and the solid surface should have a temperature below the freezing point of water. You know, the freezing point of water is 0 degrees centigrade. So if the temperature of the solid surface is below the freezing point, this results in a phase change of water vapor. So the water vapor is originally in the gas phase, and then it converts to ice. And then the ice is nothing but a solid phase, and this ice now deposits on the surface of the solid. Okay. So now the water vapor temperature goes down and reaches below the freezing point, and at least reaches the freezing point, and thereby it gets deposited on the surface. So you have a frost is occurring on a solid surface because of the water vapor that are present around it. Okay. Suppose you consider temperate climates. That means moderate climates. Okay. So normally it occurs, you can see the frost occurring on the surfaces near the ground. You can see them as fragile white crystals. So this is normally the case in temperate climates. Okay. But what happens is in a cold climate, it occurs in a very variety of forms, different forms. Okay. In cold climates, actually, as you see, the temperatures are going to be sufficiently low. So you will see a variety of frost formation, different varieties that depends on the water vapor content, or in other words, moisture content in the atmosphere, as well as the temperatures which are involved. Okay. Now, this crystal formation, the ice crystal formation, is happening by a process called nucleation. That means you must have a nucleation, and once a nucleation occurs, and from there the crystal structure forms. Ice crystals keep on forming one over the other. Okay. Now, ice crystals of frost is, mathematically one can think of what is called the fractal process development. Okay. There are methodologies to figure out how the ice crystals are getting formed, and this is decided by what is called fractal process development. So how much depth the ice crystal will form? That depends on various factors. One is the time for which these ice crystals are continuously accumulating. For example, if you go to Arctic and so on, then you find ice is there all the time. Okay, it's nothing but entire ice completely. You will see all the surface areas are completely filled with ice. See, for example, if you look at Western countries where the temperatures are sufficiently low, ice formation happens, and you see the ice occurring over the roads, okay, over the cars and various other things that happens. Okay. And also, it depends on the concentration of the water vapor content. How much that you call it as humidity. So the humidity is another important factor for the frost formation. So now the frost crystals can be of different colors. One is it can be invisible. Then you call it as a black frost. Okay, invisible. You don't see them. That means whatever light goes does not get reflected, and therefore you call it as invisible frost or black frost. It can be a clear frost. That means it is translucent, or it can even be white frost. White frost, normally, that's what we normally see. White frost, generally we see more often the white frost. The frost crystals, white, why it becomes white is because they're following the light when it is falling on the frost, the frost crystals now scatter the light in all directions. When they scatter the light in all directions, then the coating appears to be white. Coating of frost is appear to be white. Okay, because as you know, the different directions when it comes, you do not have a specific color, and therefore you have white frost. Okay. Now let's see the types of frost that can happen. The types of frost are the following. Hoar frost, that you call radiation frost. It is because of the deposition of water vapor from air of low humidity. That means less water content. Okay. So if there is a less water content, then it is because of the radiation that hoar frost gets formed. It is from the deposition of water vapor of air of low humidity. Okay. Then what happens is white frost that normally happens in humid conditions. That means you have a lot more water content, then you have humid conditions, and white frost gets formed. Window frost happens on glass surfaces, on glass windows. Okay, you have different temperature conditions, and depending upon the surface temperature of the glass, you get window frost. Then you have what is called advection frost. It is because of the cold wind blowing over cold surfaces. Then you have what is called advection frost. The black frost is normally invisible. It is nothing but an invisible ice at low temperatures and also with the low humidity. So such things happen, what is called invisible frost or black frost. There is another type of frost called rime that happens under supercooled wet conditions. Okay. So these are the type of frost which one normally encounters, starting with hoar frost, white frost, window frost, advection frost, black frost, and then rime. Okay. Now, normally what happens is you have plants, they evolve in warmer climates. For example, you have trees, okay, and different type of trees are there. They are all evolved in warmer climates. But if you have a lower temperature, they suffer damage because the temperature falls low to freeze the water in the cells that make up the plant tissue. And the tissue now gets the plant tissues, plant cells get damaged. So there is a tissue damage. And this results from the process called frost damage. So the frost actually lowers the temperature of water content in the cells, and it causes a damage. So this is called frost damage. So what happens is if you have a frost damage, then you must take care of it. So the farmers where the frost damage actually occurs implement substantial methods to protect their crops from such damages. Okay. So this is necessary so that you will not lose your produce. Okay. How is the frost formed? So let's look at the way in which the frost gets formed. So normally, suppose I put a solid surface, okay, and the solid surface, let's say it gets cooled below the dew point of the surrounding humid air. What do you know? What is dew point? Dew point is that temperature at which the atmospheric water vapor starts condensing. So if the surface, solid surface gets cooled below the dew point of the surrounding air, surrounding humid air, then the surface is now colder than the freezing point, and therefore ice starts forming on it. So the ice starts forming because the surface what you are keeping is lower in temperature than the dew point of the surrounding humid air. So what happens? The humid air, water vapor that is present in the air starts depositing on the surface. As soon as it falls, first, it deposits as a liquid, then freezes, then it forms a coating. And that can look different forms. It can be a glossy, very shiny, okay, or it can be opaque, okay, or it can be crystalline, depending on its type. This process is known as ice coating. So ice is now getting coated on the surface of the on the surface of whatever that material that is there, surface of the object, which is lower in temperature than the normal freezing point of water. Now this ice, what is formed, is different from the crystalline frost. Okay. The crystalline frost is something different. Crystalline frost actually forms, it is consisting of spicules of ice. Okay, very sharp needle-like thing, spicules of ice. Normally it projects from the solid surface from which it they go. So what is the difference between the ice coatings and the frost spicules is following. The spicules directly starts growing on the surface by desublimation of water vapor from the air. And while ice coatings are not so. Ice coating actually what happens is water first becomes, the water vapor in the surrounding first becomes water. The water falls on the particular surface. Then it's become frozen. Then you have ice, complete ice formed. Over that, you have keep on forming more and more quantity of ice. Spicules is something different. What happens is the frost spicules are formed because the temperature of the surface is much low. So what happens is the water vapor, instead of passing through, instead of becoming water, that is, it doesn't go through the liquefaction state. It goes directly to the solid state. That is, from the air state, from the gaseous state, it directly goes to the solid state. That you call it as desublimation. So the frost spicules are formed by desublimation, whereas the normal crystalline, normal ice coatings are formed by just the process of water vapor becoming in liquid and then getting coated on the surface, then which becomes solid. So what needs to be done for desublimation is the surface temperature solid must be sufficiently below the freezing point of air. It's sufficiently cold that ice formation happens without passing through the liquid phase. So you can very clearly see ice formation can happen without passing through the liquid phase. Then you call it as desublimation. So once the desublimation is formed, desublimation happens, then the ice crystals which are formed are called spicules. So they are very, very sharp crystals which are formed. Whereas in the case when it is going through from gaseous state to the liquid state, then you have what are called normal ice coatings. So this is something which you should realize. So there it can go directly through desublimation to form spicules, or it can go through the water phase. I mean, the water getting deposited, then becoming ice. Then you have what is called the normal ice coatings. Okay. So the air must be humid, but not sufficiently humid to permit the condensation of liquid to water. Otherwise, icing will result instead of desublimation. Okay. Now, crystal size again depends on temperature, amount of water vapor available, and also on the growth time. Okay, sometimes there can be wind blows, and then the ice crystals, whatever that have been grown, will be thrown off. Okay, so there should be undisturbed growth time for the ice to form on the surface of the substance, on the surface of a material. Okay, except in conditions where the supercooled water droplets are present in the air. Frost normally forms if the surface is colder than the surrounding air. So we are not having any supercooled water droplets. Okay. Since such cases do not exist, normally you have directly the frost formation on the surface, which is colder than the surrounding air. What you can see is, for example, frost may be observed in the cracks in cold wooden sidewalks where humid air escapes from the warm underground, below the underground. If suppose the warm air now escapes from the underground, then it passes through the cracks, then the upper side is actually cold. So therefore, the sidewalks, you see the frost formation. Other objects on which frost can be formed are those with the low CP, low specific heat, or high emissivity, such as blackened metals. For example, you can observe on a winter season, the frost occurring on rusty iron nails. Okay, you can see the frost formation on iron nails, although it's a good conductor, but because of the rust, okay, the emissivity is considerably high. So the frost formation happens. The erratic occurrence of frost in adjacent localities is partly due to the differences in elevation. The lower areas normally become cooler than in the calm nights. That means that depends on the surface temperature. And you suppose you have a low valleys, for example, then you will have more of frost formation in the low-lying valleys. Okay, this is something which you will normally observe. Let us now try to discuss the different type of frost. Okay, we start with what is called hoarfrost. There are multiple names. It can also be called radiation frost, sometimes also called pruina. Okay, this hoarfrost is actually referring to white ice crystals deposited on the ground or loosely attached to the exposed objects, such as wires, leaves, etc. Okay, so you can see, for example, in winter time, you can see the frost formation, or early morning hours, you can see the frost formation. These hoarfrost form on cold, clear nights when conditions are such that heat radiates out in the open air faster than it can be replaced by winds and warm objects. So there is a cooling effect because of the radiation loss. So you can see that when you have the not much disturbance by the wind, so you have zones getting suddenly cooler. Under the right conditions, the objects cool lower than the freezing point of surrounding air, much lower than the water freezing temperature. This freezing is also affected by other effects such as flood frost and frost packets, etc. Okay. They occur when the ground level loses cold air and it flows downhill and accumulates as pockets of very cold air in valleys and hollows. Okay. Now this is known as the hoarfrost. Hoarfrost may freeze in such low-lying cold air even when the air temperature a few feet above the ground level is well above the freezing point. So what is the meaning of hoar? Hoar means showing signs of old age. That's what it means, old frost. It refers to the frost that makes in the trees and bushes like white hair. Okay. So you can see the hoarfrost occurring on trees and bushes, etc. You can see them comparatively white relative to the other places. What are the different forms of hoarfrost? Hoarfrost itself has many varieties. Something called air hoar. It is a deposit of hoarfrost on objects above the surface, such as tree branches, plant stems, and wire. This is called air hoar. There is something called surface hoarfrost. It refers to the fern-like ice crystals directly deposited on snow or already frozen surface. Suppose they have a surface which is already frozen, then the surface hoar can happen. Then there is something called crevasse hoar. That consists of ice crystals which form on glacial crevasses where water vapor accumulates under calm weather conditions. Okay. So then you have depth hoar. It refers to the faceted crystals which have grown large within cavities beneath the surface of banks of dry snow. Depth hoar crystals grow continuously at the expense of neighboring smaller crystals. So typically are visibly stepped and have faceted hollows. So depth hoar means you have the multiple layers of type of frost will be occurring at low-lying areas. But normally, when the surface hoar covers the sloping snow banks, the layer of frost crystals may create an avalanche risk. You see, you always see that in Western countries, especially in the close zones of sea, the frost is normally formed, but simultaneously you have an avalanche because that is sudden falling of all the frost, whatever that is happening, ice that is falling continuously down the hill. So when it happens, it submerges all the things which are below. Okay, so avalanche can happen anytime depending on the wind directions and so on. Okay, so you see, hoarfrost has very different varieties: air hoar, surface hoar, crevasse hoar, depth hoar, etc. Okay, these are the different type of frost. Okay, sorry, yeah. The hoar and white frost may also occur in man-made environments such as freezers, industrial cold storage facilities, etc. In cold spaces, pipes serving them are not well insulated and are exposed to ambient humidity. The moisture freezes instantly depending on the freezer temperature. Okay. So hoarfrost, for example, you can see here a spider web covered in the air hoarfrost. You can see a spider web, and then the frost is occurring on its surface, okay, on the spider web. And for example, in the pipes which are not properly insulated, and when they are exposed to ambient humidity, and the moisture starts freezing instantly on its surface, and therefore you have what is called the hoarfrost. Okay. The frost may coat pipes thickly, partly insulating them, but such inefficient insulation is still a source of heat loss. So, for example, it can happen at sufficiently low temperature, that suppose a water carrying pipe and so on. If the temperature becomes sufficiently low, then ice may be formed inside the pipes. Okay. On the outside, you may have this hoarfrost. Normally, in the Western countries, you have this observation. Let's come to advection frost. What is advection frost? Advection frost is also known as wind frost. What happens is you can see tiny ice spikes. They form when the cold wind is blowing over the tree branches, poles, flowers, and various other surfaces. You can see here the frost, flower with advection frost. You can see here this violet petals. You can see the frost on the surface. Every flower, you can see the frost which is occurring on its surface. It looks like rimming on the edges of flowers and leaves, usually forms in the direction of the wind. Okay. So if the wind is blowing in some left, let's say left to right, you can see the hoarfrost occurring in the same direction. It can occur at any time of the day, maybe in the day or night, etc. So this advection frost is quite common, especially in low temperature climates, along with the presence of wind blowing. Okay. Next, we come to window frost. What is window frost? Window frost, it's also known as permafrost on ice flowers. Okay. They form when the glass pane is exposed to very cold air. On the outside is on the outside. Now, the glass pane has got two sides. No, one is outside, which is exposed to cold air. The other is inside. You have moderately moist air inside. Okay. So on the one side, you have somewhat warm condition. The other side, you have cold condition. So then in such case, what happens is once the temperature is sufficiently low, that water vapor starts depositing on that. And then if the glass pane is not properly insulated, that is, let's say, for example, single pane window, then water vapor condenses on the glass, forming the frost patterns. Okay, it can form different frost patterns. With the very low temperature outside, frost can appear at the bottom of the window, even in cases of double pane, that is two glass. Western countries, they normally use two pane window glass. That is one outside, one inside. Okay, two pane window glass are normally used. Because of the air convection between the two panes, and the glass ensures that the bottom part of the glazing unit is colder than the top part. So the frost that is forming on the surface of a glass is called window frost. For example, unheated motor vehicles, frost usually forms on the outside surface of the glass. The glass surface also influences the shape of the crystals, also imperfections, scratches, etc. They nucleate the ice crystal formation. Okay. So for example, here, you can see a window frost pattern that is occurring on the window. You can see the window frost. The patterns in a window frost form a fractal with the fractal dimensions greater than 1 and not 2. I told you that the crystal formation is a fractal process development. Okay. So it has normally a dimension, fractal dimension is more than 1, but less than 2. So the concept of fractal process development has to be seen separately. Right now I am not also aware of so much about this. So if I get more information, I will inform you again. Okay. There is a consequence of nucleation process which is constrained to evolve in 2 dimensions. However, a snowflake, for example, which is shaped by a similar process, it forms in 3 dimensions, but has a fractal dimension greater than 2. Okay. So snowflake is different from the window frost. If the indoor air is very humid, water first condenses as in small droplets and then freezes into ice. So you can see the patterns. Similar patterns of freezing may occur on any smooth vertical surfaces, but they are not obvious uh, okay, or spectacular as seen in the clear glass. So even in the vertical smooth surfaces also you may have these type of frost formation, but on the glass it is very clearly seen. You may not be able to see it so clearly in other vertical, very smooth vertical surfaces. Okay, now let's come to white frost. So we have seen hoarfrost, then window frost. Now we are seeing white frost. What is white frost? White frost is a solid deposition of ice that forms directly from water vapor contained area. Okay, you can see here white frost. Okay, that is continuously forming. White frost forms when relative humidity is very high, as high as 90%, and the temperature is pretty low, -8 degrees or lower. Okay, so and it grows against the wind direction. Okay, wind is flowing in this direction, this star fellow starts going in the opposite direction. Okay, against the wind direction. Since the air arriving from the wind direction has a high humidity than in the opposite direction. However, the wind blowing should not be too strong because it will damage the delicate icy structures as they start forming. Okay. The frost is when the frost resembles a heavy coating of hoarfrost with the big interlocking crystals. Usually they are needle shaped. Okay. So you can see here the needle shaped frost formation here. Okay, this is your white frost. Okay. So the condition here is for the white frost formation, the humidity is pretty high. Okay. Coming to another type of frost, this is called rime frost or rime, generally known as rime. Rime is nothing but a type of ice deposition that normally occurs quickly, often under heavily humid and windy conditions. You can say it is really not equivalent to that of a frost. Because since usually super cold water droplets are involved in here, so you cannot strictly call it as a frost, but then it is added on in this frost formation. Okay, this is in contrast to the formation of hoarfrost, in which water vapor desublimates very slowly and directly, whereas here in this case we have a supercool condition. Ships traveling through Arctic seas may accumulate large quantity of rime on the rigging, which are nothing but rope connections. So you see the rime frost occurring on the Arctic seas in the ships which are traveling through Arctic seas. See, hoarfrost has a feathery appearance. Rime is nothing but an icy solid appearance. So you have totally solid appearance for the rime. Okay. Now we come to another important frost called black frost. Okay, so black frost is also called killing frost. It is strictly speaking, it is not a frost because it is a condition seen in crops where the humidity is too low for forming the frost. Okay. But the temperature falls below. So the plant tissues are frozen and they start dying and they become blackened. And hence the term called black frost. So black frost happens when you have the humidity conditions pretty low, but the temperatures are also falling pretty low. So this affects the plant tissues, they all freeze, and then start dying. That's why it's called killing frost. Okay. Now, when the new white frost usually is less cold, partly because the latent of water vapor freezes, freezing reduces the temperature drop, whereas black frost can be sufficiently cold. Okay. So how do these frost affect plants? Okay, so we have seen here now various type of frost. We started with hoarfrost. Okay. So we have hoarfrost, then advection frost, then window frost, then you have white frost, rime, and black frost. So these are the different frosts which we have seen so far. how do they affect the plants? Many plants can be damaged or killed by the freezing temperature of frost. Okay. Why? We have seen. Why it is because the plant cells, whatever ice, whatever water that is present in the plant cells, they all get frozen. Okay, they become ice crystals. So ice crystal will not allow any biological reactions to proceed, and therefore the plants get killed. Okay. Now, regarding the effect of damage that happens in the plants, it varies from type of the plant, the tissue exposed, and also what is the lowest temperature that is reached. A light frost of 2 degrees to 0 degree can damage fewer type of plants, but a hard frost below -2 degrees can have some effect. Okay. More number of plants can be damaged by a hard frost. Okay, what are the, suppose from -2 degrees to 0 degree. So which plants are get damaged? Plants which are likely to be damaged by a light frost include vines, beans, grapes, squashes, melons, etc. Along with the nightshades like tomatoes, eggplants, peppers. All these things get damaged by the presence of light frost. That means the temperature is from -2 degree to 0 degree. In terms of Fahrenheit, it is 28 to 32 degree Fahrenheit. Okay. Now, plants which may tolerate, sometimes it can also benefit from this. These tolerate the frost include root vegetables. So vegetables such as beets, carrots, then parsnips, onions, etc. So these root vegetables, sometimes they may be able to tolerate this. And then also the leafy greens like lettuces, spinach, chard, cucumber, all these things are can tolerate this cooling. And then cruciferous vegetables such as cabbages, cauliflower, bok choy, broccoli, Brussels sprouts, radishes, kale, gourd, mustard, turnips, rutabagas, etc. Okay, I mean, some of the names I'm also not very much familiar, but these are the different type of plants which may be able to sort of tolerate the damages. Even those plants which can tolerate frost can get damaged if the temperature drops to -4 degrees and lower. Suppose if the temperature goes further down, then those plants which can tolerate the damages can also get into problem. Hardy perennials such as hosta become dormant after the first frost and regrow when the spring arrives. Normally what happens during the winter time, because of the frost, the plants are not dormant. They are dormant. That means no activity. But when the summer comes again, they will normally again start growing. The entire visible plant may turn completely brown until the spring month, or may drop all its leaves and flowers. We observe this sometimes, leaving the stems and stalk only. So most of the leaves, etc., are gone, and the plant gets withered, but they become dormant. But when the summer comes, they will again come back to normalcy. Evergreen plants such as pine trees withstand the frost, although all or most growth stops. Frost crack is a bark defect that is caused by a combination of low temperatures and heat from the winter sun. Okay. So there can be what I call cracks formation, okay, on the barks because of the frost. So vegetation is not necessarily damaged when the leaf temperatures drop below the freezing point, or or their cell contents. So, but what happens is the vegetation does not proceed. It becomes dormant. In the absence of nucleating site for the formation of ice crystals, leaves remain in a supercool state. Okay. And safely reaching temperatures of -4 to -12 degrees. But once the frost forms, the leaf cells may be damaged by sharp ice crystals. Hardening is the process by which the plants can become tolerant to low temperature. So it becomes really hard. Okay, but the plant stem, etc., become very hard by the process of but low temperatures. Once the temperature is low, then it becomes very hard. Okay, how do you protect these damages? See, for example, because of the cold climate, the plants do not grow and they become dormant. How do you take care of it? Normally, to prevent frost and also it reduces its severity, the following methods are generally useful. Deploy powerful blowers to stimulate wind. Suppose you have wind blowing all the time. It prevents the formation, accumulation of the cold air. There are variations on this theme. One variety is the wind machine, energy-driven, let's say, propeller mounted on a vertical pole that blows the air almost horizontally. So you can think of a blower continuously blowing the air, and air is continuously being moving in that place. Okay, air. So you use a powerful blower on the plants. Okay. Sometimes wind machines are also introduced, such as a method for crop protection, and this was done in California during 1920s, but they were not widely accepted till 1940s or 50s. Now, of course, they are commonly in use in many parts of the world. So you can use wind machines. And then another selective inverted sink, a device that prevents the frost from forming, drawing the cold air from the ground and blowing it up through a chimney. So inverted sink arrangement is normally used. So it takes the cold air from the ground and throws out, okay, through a chimney. So that means plants are not affected so much by the process of the cold air. This is methodology which has been used to prevent the effects of frost. Okay. Now what we will see is how is the frost at low temperatures? How does you see the frost at low temperatures? Okay. Let's say you can see this picture here, whatever that is shown here. This picture shows you that you have a vertical tank, but that vertical tank has lost its vacuum. Okay. Temperature of the outer body is sufficiently cold so that water vapor atmosphere can deposit on it. So you can see a white, complete white patch on this tank. Okay. And you can see all the pipelines everywhere. It is all ice clad. Okay. Now, this happens at cryogenic temperatures. So here what has happened is the temperature has become sufficiently low so that the water vapor in the atmosphere starts depositing on the cold surface. Okay. Depending on the growth of the ice crystal on the surface, there will be a thick layer will be formed. Okay. And sometimes if there is a slight wind blow, then this thick layer will again drop to the ground. So again, some newer layers will start forming. Okay. But suppose the wind flow is prevented, then the ice layer becomes thicker and thicker and then starts becoming solid mass. Okay. There is an important phenomenon which is called the Leidenfrost phenomena that happens. That's very important for the low temperature applications. And it is also applicable to the cryogenic fluids. What is Leidenfrost? Okay. I will just show you a video which indicates you what is Leidenfrost. Okay. I hope you are able to see hear the sound.
nitrogen.
Are you able to hear the sound? Hello?
No, sir.
Rahul?
Yes, sir. Yes.
Sound is clear?
No, sir.
No, sir.
No sound. Is it?
Yes.
Okay.
No, sir.
I will try to explain. Anyway, just watch. Okay. What you have seen here in this video is the following, that it is the phenomenon of Leiden-Frost effect, what is seen here. Okay. And you have liquid nitrogen. He first showed you the liquid nitrogen available here in the container. And then the liquid nitrogen boils at a temperature of minus 196 degrees centigrade, pretty low, almost 200 degrees below that of the 0 degrees centigrade. Okay. So there is a large temperature difference between the boiling point of the cryogenic fluid and the surrounding temperatures. Okay. So suppose you try to put this on the surface of, let's say, hand. Nothing happens to the hand, not continuously, but in a short time. Okay, you can pour a little bit on the hand. Okay, bare hand. What really happens is the bare hand is at room temperature, whereas liquid nitrogen is minus 196 centigrade. What is happening is when the bare hand is extremely hot for when compared to that of liquid nitrogen. Okay. So when liquid nitrogen is poured on the bare hand, the liquid nitrogen instantly boils off. Okay. It breaks into small droplets. Okay. The temperature is so high, there is a sudden boil off. So the droplets are formed, but each of these droplets has certain amount of vapor cloud. So there is certain vapor cloud around the droplet, which is preventing it from the liquid directly to touch the hand. So the liquid is prevented by the vapor cloud that is generated because of the large temperature difference. Okay. So therefore, you will find that you can pour liquid nitrogen on your hand, but nothing really happens until the hand gets cooled. Okay. If you start pouring, if you allow sufficient time for the hand to be present with the liquid nitrogen, then hand will get cold and thereby liquid nitrogen will stay, and then you will have the effects of frostbite. Okay. Now, this he also demonstrated by having a hot plate wherein you pour water on the surface of the hot plate, and at low temperatures, the water actually sticks onto the hot plate. Whereas if you look at high temperatures, when the hot plate is sufficiently heated up, then even you pour water on the surface, then what happens is the water does not stick onto the surface. Water breaks into fine droplets and then try to run away. I mean, that is try to go away from the surface, right? So that means a drop is formed, but the drop is able to stay on the surface of the hot plate because of the presence of the water vapor surrounding it. Okay. So this is your phenomenon called Leidenfrost. Professor Leidenfrost actually studied, and that's why the phenomenon is known as Leidenfrost phenomenon. Okay. So that means you can have the liquid nitrogen or hot plate. On the hot plate, you can pour water without actually, and water can stay over the surface by the cushion barrier of the water vapor. Okay, that's what he has shown here. Is that clear? This is called Leidenfrost effect. Okay, now let us see the next part, frostbite. Okay, what are the effects of frost, okay, on the human body? Now, the frostbite is known as an injury which is caused by freezing of the skin, okay, and the underlying tissues commonly affected on the commonly affected areas such as fingers, toes, nose, ears, chin areas, etc. So here you see, for example, a foot is present here on which one of the fingers is somewhat swollen. Okay, this is caused by the frostbite. In the early stages of the frostbite, known as frost nip, there is no permanent damage to the skin. Normally, you will have a symptoms of cold skin, then prickling feeling, followed by numbness, and then this numbness can be inflamed or decolored skin. Skin can be colored. Okay. So how to prevent this frostbite? It is you have to wear proper, fully covering clothing, maintaining hydration and nutrition, and avoiding low temperatures and minimizing strenuous physical activity while maintaining a sufficient core temperature. So you should use proper gloves, etc., for this taking care of this frostbite. Okay. Now, how to prevent and treat the frostbite? This is first of all, to stay warm and prevent the frostbite, you have to follow the following tips, okay, from the dermatologist. So one is dress in loose, light, comfortable layers. Okay, this is something important if you want to avoid frostbite. Wearing loose, light layers helps to trap the warm air. The first layer should be made up of synthetic material, which wicks moisture away from your body. The next layer should be insulating. Wool and fleece are good insulators, and they hold in more heat, more body heat than cotton. So the top layer should be windproof and waterproof. So this is something which one has to follow. Dress in a loose, light, comfortable layers. Next, you should protect your feet and toes. To protect your feet and toes, wear 2 pairs of socks. The first pair, which will be next to the skin, should be made out of moisture wicking fabric. That means it should be able to absorb moisture. In place a pair of wool or wool blend socks on the top of this. Your boots should also provide you adequate insulation. They should be waterproof and cover your ankles. Make sure that nothing feels tight, and cotton clothing, as tight clothing generally increases the risk of frostbite. So you should make sure that you have a proper type of protection for your feet and toes. You should also protect your head. To protect your ears, head, wear a heavy wool or fleece hat. If you're outside on a bitter cold day, cover your face with a scarf or face mask. The warm air you breathe helps you to prevent the frostbite on your nose and face. This certainly helps you to protect your head. You have to protect your hands. Wear insulated gloves to help, to help protect your hands. You have seen in the video, the person was using a gloves. Make sure snow cannot get into your boots or clothing. The wet clothing generally increases the risk of developing the frostbite. Before heading outdoors, make sure that the snow cannot easily get into your boots or clothing. Okay. While in outdoors, if you start to sweat, cut back your activity, cut back on your activity and unzip your jacket a little bit. Now, keep yourself hydrated. That means becoming dehydrated also increases the risk of developing frostbite. Even if you're not thirsty, drink at least 1 glass of water before you head to outside. And always drink water on a or a sports drink before the outdoor workout. In addition, avoid alcohol as it increases the risk of your frostbite. Now, they recognize the symptoms. In order to detect the frostbite early, it is most important, while it is most treatable, it is important to recognize the symptoms. First sign of frostbite include the redness and the stinging, burning, throbbing, prickling sensation. You can feel the sensation, and sometimes it will be followed by numbness. So if such is the case, try to return back to the warm areas as quickly as possible. Okay. I think I have more or less covered the frostbite, what are the different types, and particularly in relation to the cryogenics. We talked about the Leiden frost and also the frostbite behaviors. How to take care of oneself because of in times of frostbite. Okay. So I think I will stop this lecture here.